Profile projectors, also known as optical comparators, are sophisticated measuring instruments widely used in various industries for non-contact inspection and dimensional measurement. These instruments allow for the precise examination and measurement of small components, providing magnified profiles of objects on a screen. By utilizing optical principles, profile projectors offer an accurate and efficient method for quality control, ensuring the conformity of manufactured parts to design specifications. Profile projectors have become indispensable tools in modern manufacturing processes, particularly in industries where high precision and tight tolerances are paramount. Their ability to provide magnified images of complex shapes and contours makes them invaluable for inspecting intricate components such as gears, threads, and cutting tools. The non-contact nature of measurement ensures that delicate parts are not damaged during inspection, preserving their integrity and functionality. The versatility of profile projectors extends beyond simple dimensional measurements. These instruments can be equipped with a range of accessories and features, allowing for the measurement of angles, radii, distances between features, and even surface roughness. Their ability to perform both linear and angular measurements makes them highly adaptable to diverse inspection tasks. In the following sections, we will delve deeper into the components, working principles, and applications of profile projectors, uncovering the intricacies behind their accuracy and versatility. From the basics of their operation to the nuances of error mitigation, this exploration aims to provide a comprehensive understanding of these essential metrology tools. A profile projector comprises several key components that work in unison to facilitate precise measurements. Understanding the function of each component is crucial for comprehending the overall operation of the instrument. First, we have the light source. The light source is fundamental to the operation of a profile projector. It typically consists of a halogen bulb or an LED that emits a bright and consistent light beam. This light beam is directed towards the object being inspected. Next is the magnification lens system. This system comprises a series of lenses responsible for magnifying the image of the object. The magnification level can be adjusted using a knob or dial, allowing for a clear and enlarged view of the object's profile. Then there's the projection screen. The projection screen serves as the display surface where the magnified silhouette of the object is projected. It is usually a translucent screen with a grid or scale etched onto its surface. This grid facilitates accurate measurements by providing reference points. Another important component is the XY coordinate stage. The XY coordinate stage is a platform on which the object being inspected is placed. It can be moved precisely in both the X and Y directions using micrometer screws. This movement allows the operator to align specific features of the object with the crosshairs on the projection screen for measurement. Some profile projectors are equipped with a rotary protractor screen. This additional screen, concentric with the main projection screen, enables the measurement of angles. It is graduated in degrees and can be rotated to align with angled features on the object's profile. Lastly, modern profile projectors often feature a digital display unit. This unit provides a digital readout of measurements taken, eliminating the need for manual readings from the graduated scales. Digital displays enhance accuracy and ease of use, streamlining the inspection process. The profile projector operates on the principle of optical magnification and projection. The process begins with the light source, which emits a focused beam of light. This light beam is directed towards the object being inspected, placed on the XY coordinate stage. When the light beam encounters the object, some of it passes through or around the object while the rest is blocked. This creates a shadow or silhouette of the object. The magnification lens system then captures this shadow and magnifies it, projecting it onto the projection screen. The projection screen, typically made of translucent material, allows the magnified silhouette to be clearly visible. The etched grid or scale on the screen serves as a reference for taking measurements. By aligning specific points on the object's profile with the grid lines, operators can determine dimensions, angles, and other geometric features with precision. The magnification level can be adjusted using the lens system, allowing for the inspection of both small and large features. Higher magnification levels provide a more detailed view, while lower magnification levels offer a wider field of view.